Welcome back to the channel. Today's video, we're going to do something a little bit different. Usually on this channel, we do a lot of our data processing with tools like Pandas and NumPy. But in today's video, I want to go over two techniques, filter and map, which are built in Python functions, which means we don't have to import any special libraries or build any special code. We can actually just use these particular keywords, filter and map, to do our data analysis. So let me show you. In this case, I have a simple list here, 2, 3, 67, 84, etc. And let's say I want to filter just the even values, which is a common starting point. We have this filter keyword here, and you can tell it's a Python keyword because when we type this out, it is green. And if we type a parenthesis and shift tab, this gives us some initial idea of how this works. And so this will return an iterator yielding, that's a keyword, those items of an iterable. So the iterable would be something like this list or a tuple or some other object whereby you can loop through. And so let's say we want to filter the even terms. To do that, we can do a couple of things. I think one of the maybe more straightforward ways would be to use a lambda function, and we will loop through with x being our iteration variable. And let's say we want x modulo 2, where that equals 0. So any object where we divide by 2 and we get 0, we know we have an even object. And the next variable we pass in will be our list, which we have stored as LST. And if we loop through, we get this object here. And recall I mentioned that yielding is a keyword which tells you what we're getting back, which is this iterator. And so with iterators, you typically have to do something to actually loop through this object. So right now it is not actually computed. One method we could use is the list function. And when we do this, we'll actually return a list of our filtered values. So in this case, we're looping through, filtering where this statement is true, x modulo 2 equals 0, and we're looping through list. And so we now loop through this list and we return these values here. And so we can loop through other things. We can actually write functions. We don't have to just use these lambda expressions, but we can actually write our own function to do this as well. And so let's say we want to write a function that's called large values. We'll say def large values or large vals, and then it will pass in an object called val. And let's say we want to return where val is greater than 50. And so we'll return values where this statement is true. And we will actually pass this through our filter object. So again, filter, we'll pass in our large val method we just defined, and we can pass in our list. Oops, let's get rid of this. And we run this again, we get this object here. And one way we could get around that is to just wrap this with this object. And you see of our larger values greater than 50, we return 67 to 84. So this is very useful for some simple data analysis in a way that can be fairly clear. I actually prefer this method. I really don't like to use lambda expressions. I usually prefer to either write a function or do this with a list comprehension. However, of course, we have chemical applications for this, as well as a lot of the focus of this channel is around how we can use these tools for chemistry. And so let's say we want to filter our list of molecules for molecules that contain an oxygen or a nitrogen, for instance. So we can write a similar type of expression where we say filter, and let's do a lambda expression again. And let's loop through x would be our word, and we'll look for in x, and we'll pass in moles. We have our object there, list. And we get this list where we have O in our list of elements. We can replace this with N and get a second list as well. So you can see how we can do our data analysis in fairly simple ways using lambda expressions, but primarily centered around using this filter object. So we have other options too. So we can use map. So let's take this same moles list, and let's say we want to map all the compounds that have a C, that have a carbon in them, using a similar approach. And map works similar to filter, whereby instead of returning a true, false, and thus a reduced list, we can actually map new variables on top of these respective values. Again, this is a technique we've done a lot with the map function and pandas, but this is also a core function in the standard library. So let's see what we can do here. Let's make a function called C containing, and we're going to pass in a string. And let's say if C in string return organic, and then otherwise or else return string. So in this case, nothing would happen. And as we have done before, map, let's do this with a lambda function. It gives us an easy way to iterate through these respective list values. Lambda x C containing x, and then we'll pass in our moles list or moles tuple. Again, we have the same iterator object, and likewise, we can approach this a couple of different ways. In this case, I'm showing how we can use list. There's another approach where, because it's an iterator, we actually can use the next keyword. And so instead of this here, let's copy this, and let's just call this moles2. And we can use the next keyword and return moles2. Next is one way of stepping through this iterator object. And so we could just print this here. And recall, don't need that anymore. So here we're printing that. If we were to print this again, we'll actually loop through this list and continue until we go through the entire list. So as you can see, this is one way to step through this. I'm just using print statements to run to the screen. But if you did not want to compute this, or you have an incredibly long list, you don't want it all stored in memory at the same time, this is one way where as you build some other processes around this, you could step through this iterator and then do some additional work. This is the same type of object we have here. So everywhere where you generate this generator here, you can use that next object as well. So these things work pretty well together. It makes it way more efficient in some cases where you, again, don't want to store all this in memory. However, I generally still prefer list comprehension. So here I have this list comprehension here where I essentially do the same thing as this C containing function. And to me, this tends to make more sense. I tend to prefer to incorporate these as well, and you get your list back. So the way list comprehensions work is also relatively efficient in Python, but I wanted to really focus on how we could do this using lambda expressions, using next, and now using a list comprehension just to sort of round this off and show there's multiple ways to approach this, and it really does depend on what you want to do next. In any case, I hope you enjoyed the video. Peace.